Vipra is a research fellow at the AI Now Institute, where she focuses on competition issues in frontier AI models. She recently published the report Computational Power and AI, which focuses on compute as a core dependency in building large-scale AI. We found this report to be an important addition to the work covering the generative AI industry because compute is incredibly important, but not very well understood. In the report, Zai breaks down the key components of compute, analyzes the supply chain and competitive dynamics, and aggregates all the known economics. In this interview, we talk with Zai about the report, its implications, and her recommendations for industry and policy responses. Thank you so much for joining us. We're excited to talk to you today.
Thank you for having me.
What inspired you to write this report?
Two things I would say. One, that compute is a big input into AI systems. We realized that it was quite a preoccupation in AI companies. And the other thing being that compute is already emerging as a level of AI governance. It is driving policies like the US government's export controls. So it is front and center in AI governance as a topic, but we realized that there was no comprehensive report on compute. So we decided to fill that gap and also to increase our own understanding of the topic.
I found your report to be very helpful and fascinating. I mean, the compute is a big topic. It's one that is also pretty mysterious, right, in terms of uncovering the facts still. Why don't we start with, can you define compute for our audience in terms of how you think about it? Sort of what are the key components in compute so that people can sort of get their heads around what it actually means?
Yeah, I think it's a really good question, and this is how we start the report as well, because compute, what you mean by compute can really differ based on what you're talking about and the context in which you're saying it. So at a very basic level, it can mean the chips that are used to train or even run an AI system, so graphics processing units or GPUs. It can also include the software that is used to run these chips because they're really specialized. You need specialized software to run them. You need domain-specific languages as well, and sometimes these are part of the compute stack, as it were. But sometimes you can also use compute to describe the entire infrastructure that is data centers that allow the use of all of these chips together in one set for the training and running of a model. So it really depends on what you're talking about, and we look at all of these meanings of compute in the report.
I liked how in the report you talked about sort of two big use cases for compute, the big two categories. There's a lot of conversation and a lot of coverage around training and how much it costs to train these models, mostly because there's some amount of data, right? So some amount of disclosure, at least in previous versions. Now it feels like we don't really know. You know, there's sort of supposition about how much GPT-4 costs to train because the major players in this market decide that it's a competitive advantage to keep that quiet. But then there's this other major category of inference, right, which is the running of the model when you actually are prompting and getting a response. And it feels like that's still pretty much a mystery. Is that true? Like, how much do you feel like you're able to get your hands around exactly how much it costs to execute a prompt, if you will?
Yeah, it's really opaque, and it was one of the most challenging problems we had in trying to find out how much inference really costs. And, you know, there's very little published material on this because it really differs from chip to chip, and also the kind of model you're using, how much you're optimizing for that particular set of chips, and so on. And some of the strongest evidence we have is, for instance, Sam Altman's tweet about how much inference costs, and just people talking about this. So there is no good data, but we know that one inference, so one query, for instance, to a chatbot costs very, very little, but that these costs really add up if you have millions of users. So millions of people querying ChatGPT, for instance, would eventually lead to the inference cost as a whole being larger than the training cost as a whole. So while the unit cost of inference is really small, the total cost is really quite large.
Yeah, and it feels to me like there's this huge band, because if you go to a chat GPT today and you ask, 5 different questions and get 5 responses, that'll be relatively small. But if you are interacting with something like Pi, the emotional AI app, and having a long conversation that might be, it could be hours of time over a span of just a day, having this long, in-depth conversation, that would seem to be, that much more, right? Sort of a linear progression of cost of compute.
Yeah, exactly. And especially if you're a business, these costs really add up. If you're a business based on using an AI model from another business, so for instance, from OpenAI, you really have to think about the cost of inference, because this is going to end up being your primary cost, even if it's replacing people. So there was a time in which I think a few businesses figured that actually it was costing the same as hiring people, because the cost of inference was so high at the time. Now they're low, but we also think that sort of the costs of inference should really be public, or should at least be disclosed to regulators, because without knowing what these costs actually are and how they correspond to the price paid by businesses to use these models through APIs, it's hard to establish whether there is predatory pricing in any sense. Whether which is to say whether businesses or the AI companies are pricing them way below cost in order to capture markets or not. So I think it's very important information to have out there.
That's interesting. I hadn't thought about that, because you pointed out it's an obvious pricing strategy.
Sure.
Because I think one of the things that I particularly appreciated about this report was that it nudges the reader out of any state of sort of complacency about the cost of compute, because we just haven't thought about it for 20 years. It just hasn't. Everything. Services have been free, been paid for by advertising, blah blah blah. But these costs are so significant and so much a part of the decision as to how to deploy and even to design products, I assume, that you actually have to sort of start with this in a way that we've never had to start with it before. Over the last decade, people have moved entire corporate infrastructure into the cloud. There's now significant lock-in and switching costs in terms of cloud provision. And suddenly this report sort of makes it really clear that this whole ecosystem is really about the fact that the cloud is not free and at all. And if you were worried about your cloud costs before, then you really need to be much more sensitive to them from now on. In terms of thinking through helping people understand how significant this could be, and what are the kind of key questions they should have in their minds as they think about adopting this technology, replacing people, designing products. How many prompts should people be allowed to use before they either are sort of the conversation is allowed to sort of tail off. What are the key things that you've been left with as the questions that people should be asking when they're thinking about adopting Gen AI?
Yeah, I think one, that you're right, it has become quite a significant question, and I'll just elaborate on that in a bit. But also, two, that we need to look at two different markets. One, the market for the AI models themselves and everything that feeds into that, including compute. But then also the downstream markets, so businesses that use these AI models to carry out their work. So in terms of the significance of compute, I think it has become much clearer in recent years because OpenAI's whole turn towards trying to make profit and not providing all their models publicly was motivated, of course, by safety concerns, but also by concerns of the cost of compute. And this is why they had to seek out the agreement with Microsoft. Similarly, for DeepMind, it agreed to be acquired by Google because the cost of compute was so high, and then it was merged completely into Google recently because no one wanted to duplicate the cost of compute within one organization. So it is quite significant. I think the starting point that we had for this report was because the scale of models has gotten so large. To make a highly capable model, you have to have a really large model. And for that, you need to use highly capable chips. We started from this fact from a CSET report that said that if you use trailing node chips, your model will be at least 33 times more expensive than a model that uses the most advanced state-of-the-art chips. And I think this is something that businesses downstream should really take into consideration, because if you're trying to build your own model, this depends on how good you want your model to be. Perhaps your business can do well with just having a model that is not as good as GPT-4, for instance, but approaches those capabilities, and then you can have a smaller model and not worry about it. But if you want the highest capabilities that are out there, you have to depend on these models, because unless you are part of a big tech group, it's going to be really hard for you to invest and start building these models from scratch.
The 33 times is something
staggering.
So we just for those who haven't been tracking, we're in the world of where people suppose that some of the training of these models is getting to the an order of magnitude, sort of like $100 million. Like that's where we're sort of headed. 33 times would mean that would be 3.3 billion, right? Let's just get the numbers in scale, and that points to how important those most advanced chips are, right? And you do talk in the report about industry consolidation or sort of concentration, and what I'm curious about is if you can talk a bit about that real concentration. Where is it? You talk about it in different parts of the stack. I found that to be really helpful to sort of see beyond. Right now the narrative is it's all about NVIDIA, right? Well, we know that because that's obvious. They're the GPU company. But you talk about other points of concentration, and I think it'd be helpful if you could just sort of talk through a couple of those.
Yeah, I think it starts all the way from the designing of the chip, which is what NVIDIA does, but then the manufacturing of semiconductors, which I think is a notoriously concentrated industry. I haven't seen an industry that is more concentrated. For instance, ASML in the Netherlands is the only company that makes one of the components that is required to manufacture semiconductors. You can't do without it for the most advanced chips. That's just one company. TSMC is the only company that can build certain kinds of advanced chips. Again, that's just one company. There's Intel, there's AMD, but primarily it's these three companies. There's also electronic design automation software, which is the software that automates the design of the chip itself. And that market is less clear in terms of what is really going on there. But again, it's a few US companies that dominate here as well, is what we know. So it's wherever you look in the supply chain for AI chips, there is a significant concentration. So there are multiple points where you would have to intervene if you so desired. I think that you can't have a single track approach to this market.
Hi, it's Dave with just a brief interruption. If you're enjoying our podcast, we'd love it if you'd share it with someone who you think might enjoy it too. And check out everything that Artificiality has to offer at artificiality.world. Reach out anytime. We'd love to hear from you. Back to the interview. At one point in the report, you talk a bit about recommendations for policymakers. I'm curious if you could highlight some of those that you think are most important. I mean, especially in this question of concentration and access to capital, because the only way to disrupt the concentration that's in the market is for new companies to be started. Those new companies that are going to be started are going to come from large pools of capital. So it's sort of, there's some level of diversification in the venture capital industry, but it's still going to be highly concentrated. But can you talk a little bit about the sort of recommendations you have for policymakers?
Yeah, one of the first things we say is that there is a clear case for antitrust scrutiny, in that there are, like I described, so many choke points along the supply chain for AI compute. So we really think that there should be more scrutiny into changing the structure of this market entirely. As well as some new recommendations that haven't been made before, such as looking at the software layer of compute. So, for instance, NVIDIA's CUDA, which, aside from being just very optimized for NVIDIA's own chips, it also has a really active developer ecosystem. And for any competitor, that's almost impossible to overcome as a barrier. If antitrust authorities do not want to break these layers apart, they can also consider some kind of interoperability. But this sort of policy action requires a lot more study and scrutiny. We also talk about non-discrimination obligations for different actors in this ecosystem. It's early days, but I think the actions required for creating competitive markets become much more severe the more locked in the monopoly gets. And ironically, ex-ante regulation like this can be less interventionist if it's done at the right time and the right manner. We also talk about data protection because, it's not about compute, but the more you are unable to compete on the basis of compute, the more important data becomes. So the Palm 2 technical report talked about how better quality data improved the capabilities of a model that was smaller than another model that didn't have such good data. So data becomes really, really valuable, but we know that most of the data that is valuable is controlled by a few companies. So we talk about how data protection and other laws can help ensure that the most capable models aren't built only by the companies that control most of the data. We also think that the incentives for paradigm shifts bringing about paradigm shifts are really high. So this is not per se a recommendation. But the fact that the UK has decided to pour in so much money into quantum computing, the fact that China has very little options now, given the export controls, than to, aside from circumventing those export controls, also looking at new paradigms such that current technology becomes irrelevant. So we are expecting sort of new developments in some sort of new paradigms. Too early to say which one. I think these are our primary recommendations. I can just go into any one if you would like.
Before we do that, because I think that would be really valuable, but some of these numbers, I think, giving people a bit of a perspective on we're not talking about double or triple here. We're talking everything has a zero on it. It's an order of magnitude difference. There were some sort of startling stats that I think really sort of shift your mindset or give you there's sort of almost a call to action that's just so big, like you had the 33 times. Mm-hmm. But the difference between what academia has access to versus what private companies have access to, I knew that was big, but I didn't know it was as big as as in the report, as you outline in the report. And there's a number of these quite startling stats that they don't just speak to the scale of what we're facing or what people expect in terms of the scaling aspects of compute and how big these models can get. They actually speak to almost a fundamental rethink of how you actually even conceptualize where this compute is going to be. Who's going to pay for this electricity? Where's the water going to come from? Who's going to have access to it under what sort of conditions? If the brute force of scale and compute is this big, how do you think about creating extraordinarily valuable data sets? It's so strategic to think about this, the sheer scale of the numbers here. What were some of the things that sort of surprised you that you went, whoa, wow, that's bigger than I thought?
Yeah, no, I think first I fully agree with you. Writing the report really made us question about the need for such an extractive and expensive resource to be put towards AI models in their current form, especially because at the moment the drive towards a use case seems to be towards making personal assistance, and we really just started questioning the need for this use case to use up these many social and ecological resources. We think we're far beyond the time that AI research was motivated with a view towards true transformation, social good. It is very evidently market driven now. At least that is the predominant driver. And, even the utopianism from some AI companies is now tinged with a sort of market realism. So we think it's the perfect time to take a step back and assess the state of AI. And compute, of course, is a great vantage point for that clarity. In terms of what really surprised me, there were a couple of things. One, like you said, the difference between academia and industry. So there's a report that is, I think, yet to come out that we cite that says the largest academia developed model uses only 1% of the compute that was used to train the largest industry model. And that is such a large difference. And it has happened in such a few short years. It has caught everyone by surprise. At least it caught me by surprise. I was also surprised at some of the emergent strategies of NVIDIA and the cloud companies. So NVIDIA wanting to create more competition in the cloud market so that their own returns are not affected because they supply to the cloud market. So they're trying to use companies, in our view, like CoreWeave to sort of create this competition in the cloud market. And also the effort by cloud companies to create more competition in chip design by trying to design their own AI chips. In this mix, there are also AI startups that don't want their own cloud providers to compete with them down the road. And so they're choosing cloud providers who don't have any plans for creating AI models or who won't push their own chips on them. And so it's a market where everyone's trying to create more competition, but they're also all trying to consolidate their own little markets. So, and it's ultimately all a very small group of companies. So it's almost really primed for intervention. I was also a little taken aback by how much of the AI market growth is encouraged by cloud service providers' own incentives to grow. So it turns out the more AI models are developed and used, the more demand there is for cloud services. And it's often not possible to disentangle how much of AI's promise is seen by end users and how much of this promise is conveniently professed by cloud companies for their own market reasons. So that is even now a little difficult to understand.
What are the top couple of things that you really wish you could have figured out? Like if you were saying, if there was just a couple of things that I wish was disclosed, or I wish that was that you could have found some data on, what would have been the most important things?
Exact costs and exact prices would be just amazing. That would really just, there's so much speculation that needs to be done now, but that would really be very useful. And I'm hoping that if there is any regulatory action, that these costs are revealed at least to regulators. I think, beyond that is really about how deep you would like to go into the technical nature of these things. But it's actually the economic information that is really quite opaque at the moment. No one even knows the total training costs exactly of models. They don't know, how many chips were used and so on.
Yeah, we're sort of getting used to, as a user, this sort of $20 a month seems to be the price point. $100 a year is what they seem to be charging. But as you highlight, we have no visibility to know whether that is a profitable business model, or if we're essentially getting sucked into using a product and eventually those prices are going to go up because they're operating at a loss today, or based on your usage it's going to change because inference cost scales based on the number of usage. Or if there's some sort of opportunity to reduce costs. We're just sort of, in some ways, blindly rushing into this future without understanding enough of the basics to know what it really costs. And I wonder how long it'll take before we really do know. There's some level of public disclosure, obviously, from the major tech companies, but they don't break down a lot of these numbers, in the way that we'd like to know. And, the biggest company sitting out there is OpenAI, and they're clearly not open anymore. But I don't know. I mean, I think that's sort of a conundrum, I think, for everyone, is to say, well, we're not sure whether this is sustainable or not. I have noticed myself one new thing that happened for me in ChatGPT, I think it was just this week. So I was asking it to do something, and I had it create a list of, I think there were 14 things. And I said, okay, but go back and write 3 descriptions for each of those 14 things. And it went through and it said 1, 3 descriptions, 2, and so on. No. Complete the list of 14. But it fell, and that just happened to me a few times in a row in the same day, and it sure felt like there's a change and a tweak in the application that is gating how long the response is, how many tokens it's generating to try and reduce that inference cost. So I think that, along with reading this report, it was like it was the perfect timing to go, you're totally right, that it could be, the inference cost is way more expensive than we're thinking. And they're redesigning the product to try and reduce that cost.
Well, and also, we have no insight at all into whether all prompts are the same, right? So, you could, when these first came out and they were strongly rationed, people developed these extraordinary long prompts. People would spend an hour putting an essay together and then hit go. And now I've noticed that you don't get great answers out of ChatGPT if you have these really long prompts. That's almost like it's starting to collapse, and the product designer's responding to this cost. It's all very anecdotal. There's no way you can really test it, or no way we can really test it. And I haven't seen anyone look at different styles of prompts and whether or not it's there's any impact on cost. But you've got to kind of think there is, right? You've got to believe that not all prompts are created equal in terms of their cost.
Yeah, I think that that might actually be the case. Some AI companies are now increasing the context length in that you're able to ask for input longer prompts and get longer answers. But I think that really might be the case. And I think that eventually whether this whole industry is sustainable, economically or not, really depends on whether the end use of these models ends up being as economically useful as people think. So if the businesses or consumers who use large language models actually start seeing some economic returns, it will make sense to pay this much for it, and it will make sense to use all of this compute, at least in a commercial sense, to run these models. But I think that will take a little bit more time to actually pan out, and for everyone to realize how much commercial sense these models really do make for businesses.
There's some forecasts out there about the growth of the cost, right? And it's mostly around training, again, because people haven't really figured out how to analyze and forecast the inference cost. But the training forecasts, some of them show continued exponential growth, and going so far as to finding that crossover point, because everybody likes that, of crossing over and becoming greater than the U.S. GDP, right? I'm curious what you think about these sort of forecasts and the growth as you step back and looked at it from a global perspective. Do you think that those how realistic do you think those forecasts are in terms of the cost that will be required, but also the cost that can be absorbed?
Yeah, I don't believe that the costs can be absorbed just yet because, like I said, we're yet to see the actual economic benefits of using these models at such a large scale. But if we see those benefits, and they would have to be really quite large, only then are you going to justify these costs. But I do think that they are realistic in terms of the projections themselves. If you do want larger models, you're going to have that much compute, unless there are very good breakthroughs in using less compute. And we've talked about some of the ways in which that could happen too. You could just have really good chips. The next generation of chips could be so good that you don't need so many of them, and that they don't cost so much. But that's a bit, it's not a great bet. You could use smaller models and try to make them better. But again, the research shows that they don't really approach the capabilities of large models. You could use decentralized trainings, but there are sort of unsolved problems in terms of security and the heterogeneity of data in that. Or you could just have better quality data, but we're not really sure about, the actual returns on that either. So it feels like at the moment there is no escape from scale if you want to keep getting better and better, along the same LLM paradigm.
One of the major tech companies that mostly gets overlooked in this conversation is Apple. They haven't come out with a major LLM or image model. They're not big consumers of GPUs. They're relying on the open source community, it appears. Although it's Apple, you never really know what's going on. And the scale of the company, they could bury quite a lot inside the company and you wouldn't really know. But I'm curious if you have any perspective. One of the ways that we've been thinking about it is that Apple actually has a unique advantage in that their, if you will, inference chips, right, the ones to actually run the model, are actually in everyone's iPhones. And so they're an intriguing sort of counterpoint to all of this, because they don't need to go buy data centers to run these models. They've already been paid to ship iPhones that can run models. But I'm curious if anything that you did in your research came up that can shed some light or had any perspective on Apple, because it is usually the company that's kind of left out of the conversation.
Yeah, the only thing I can think of is the exact thing you said, in terms of if decentralized training really takes off, and if Apple or someone else decides that it's time to solve the problems that exist with decentralized training, Apple could be in a very good position to take advantage of that. But I don't think anything else really came up. But it is quite a notable exception at the moment.
It's been a short amount of time since the report came out. I'm curious what kind of reaction it's gotten.
Yeah, from what I'm seeing, people are really happy that it's comprehensive. Like I said, I don't think a report that tackled all the questions people had about compute really existed before. So I think that has been the biggest value add. And like you said, I think it has made it clear for a lot of people from what they're saying, what the market is really like and what the interventions need to be. So I think people are finding it easy to come to their own conclusions on the basis of all the information in the report about what needs to be done about the compute market. I think everyone's converging that something needs to be done. So.
I'm curious about, and it's a bit of a backtrack here, but there's two other things that I'm curious about from a competitive sort of dynamics perspective. One is the opportunities for collusion. That we may not have seen in the compute market before. And the other is the sort of unexpected or value shifts that have been kind of local but may become more global. And what's on my mind there is these data centers are colossal. They're going to get more colossal. And they're often built with some degree, especially in the US, of tax break or cheaper electricity cost. You might be offered incentives to build in a certain state because you can get electricity at 0.5 cent a kilowatt hour or something like that. And ultimately, that's a pretty big value shift that happens. But is there something about the scale of this that just fundamentally shifts that and alters that? That was one of the other things that had occurred to me, just simply when you're talking about the amount of electricity that you're going to and resources that you're going to consume with some of these forecasts through into the late 2020s, early 2030s. It feels like it's a different world. It feels like it shifts to a different kind of state of pricing as much as anything.
Yeah, I haven't thought very deeply about that, but I saw a report today, I don't know by whom, which said that data centers as a whole today consume more energy than entire nations, and several nations. So I think that this is a question that people are going to have to ask because, it's obviously a crucial time for climate-related questions. And is this really the sort of end we want to put all our scarce ecological resources to, especially at subsidized rates? I think is going to be a big question.
Well, that might be a topic for a future report. I think there's definitely some pretty interesting data to dig into in terms of the sustainability. I think you're right, and it's a really well put sort of frame. Is this where we want to put our scarce resources right now? And part of that key question is how much resources. You hear the story of some 5 to 50 prompts consumes a 16-ounce bottle of clean water. We sort of have little anecdotes, but so far I haven't seen a very thorough report like yours on the sustainability of the industry. But maybe you'll do that next.
I was going to say, what are you working on next?
Yes, I guess that is how about that as a final question? What are you working on next?
I'm working on a document just looking at what strategies a country like India should have in this sort of compute market, because it's not a world leader at all in compute, and not just India, but what other countries should really think about when they're thinking about compute strategies, because it's really clear what the US is thinking, it's clear what China's thinking, but it's to an extent clear what some European countries are thinking. It's really not clear how other countries can begin to think of maintaining strategic autonomy in a market that is so global and yet so concentrated. I'm also looking at digital trade agreements and how they affect AI regulation. I think it's a topic that not a lot of people work on, but I think it could be really interesting to look at.
Fantastic. Well, we look forward to reading those. Thank you very much for joining us. This has been great. Highly recommend our listeners read the report. We'll drop a link in. It's very approachable. It's very easy to read. It's well done. And it's a good grounding point. I think we all hope for greater understanding and greater insight, but I think you've done a wonderful job of pulling together everything that's knowable today. So thank you very much for joining us and talking about it.
Thanks so much for having me. This was super fun.